Hello YouTube. Today I'm going to be demonstrating the software workflow process as described by Langmuir systems for CNC plasma users. I have a lot of requests for making a video as I do a lot of Zoom meetings with a lot of you, describing how to either draw something or how to fix something or how to make a drawing a cut ready file. So again, today I'll be demonstrating that with a simple test piece that I use mainly for dialing in tables and that sort of thing. So we're going to be drawing a 2.5 inch square with 2 3/4 inch circles. We're going to incorporate a radius in each of those, and just again talk about profile development and that sort of thing. So let's kick it right off. So first thing you got to know is when you first open up Fusion, you're going to see this little box here at the top right, and this basically just gives you the orientation for how you're looking at your drawing. So we remember from math, y-axis up and down, x-axis left and right, and then z-axis would be up towards you. So we just want to get the correct orientation. That's most important. Make sure you're in the correct plane here. So I like to just go here and click top, and now we're in the right orientation here. So first thing you're going to do is, if you don't already have a file in front of you, you want to create one. Like I said, that test piece that I talked about, we're going to go ahead and go here, create sketch, and start with our line function. So this right here is just where we're going to start our little origin point. You can see that little box comes up. All you're going to do is click it, and we are here. We can start drawing. So if you've never used Fusion or any CAD program, it's really simple. You could begin to draw with simple lines and connecting them, or you can utilize a couple features here that allow you to create those shapes. So let's say I want to create that square, I could do so here, or even a circle and that sort of thing. So really easy, really cool. But we're going to skip all that. So again, we're going to just draw a simple 2.5 inch square. So I'm going to take the 2-point rectangle here. And that 2-point rectangle just basically allows you to choose a start point and an end point. So if you have a specific dimension in mind for creating parts, you can simply, if you look there down at the bottom, the dimensions, you can see them change as you open and close it. You can actually type in a number here, a predefined number. And so now we have our x-axis distance, 2.5 inches. And if you hit tab, you can choose the other one. So let's make this 2.5 inches. Now this is really useful for, just typing it in and getting those dimensions. If you know those dimensions already, you could just type them in and it creates that box in a certain way. You could also do that for lines if you want. Just take a line, make it 2.5 inches, and then you can take another line. We're going to connect from here and go 2.5 inches. Oops, I went 5 for some reason. So again, we're going to go 2.5. And then if you want, you could just create that line. You could see again. And this right here, because I have the sketch grid here, the background, because I have that sketch grid open, I'm also utilizing another feature called the snap feature here on the left side. So what the snap feature does is, depending on how far you're zoomed in or zoomed out, these little boxes. So here, each little box is 1/10 of an inch increment. So you can see it just snaps right to that. So you can utilize that feature as well. Or one other one that I really like is, had this been a really tall line and really far out, you can simply hover over the endpoint here, go up, and it automatically creates that stop for you. So click that, and I could go straight down, and click that, and we've created our square. So again, we created a square with lines in it, or a square with that 2-point rectangle feature. So here, we don't need both of these. We're going to delete this. All right, now For a test piece, I like to add a radius here. So I like to watch my corners, see how clean they're cutting. And it, kind of tells me a couple things about my machine. It tells me how it's cutting those corners, that radius, especially if it's a clean transition from this straight edge to radius, and especially on the lead in, lead out when the torch comes in to start cutting your piece, and as it leads out when it's done cutting. So I like to look for all that. That's why I really like using this test piece. So again, we have our 2.5 inch square. Let's add a radius. So we have our fillet feature here. We're going to add a radius to each corner. Now I want to make this a 1/4 inch radius. So all you got to do is click any one of these corners. You can see there's a feature that pops up. And I want a 1/4 inch, so 0.25. And instead of clicking enter, now that I have my 0.25 selected, I can go ahead and go to each corner here and apply that same radius to all my corners by clicking them. And once I have those 4 corners selected, once I'm done, I just hit enter, and that radius is applied to each corner here. That's pretty cool. And another thing too, I mean, even if it doesn't call for it, when I'm making parts, when I'm making signs, I like to add a little radius because I just think it looks professional instead of having a sharp corner or something to catch on something. So we've got our radius, we got our square here. Now we are going to add 2 3/4 inch circles to this. I do want to offset them. I want it to be about 1/4 inch off the edge here. So to do that, I like to just use lines here. So I'm going to go halfway down. So as part of that snap feature that I was talking about, um, you also have you have these cool little indicators here where it shows you what the halfway point is. So where our radius ends here and where a straight line begins, you can see that is an endpoint. Um, when you draw a line, you actually also get a midpoint indicator. So here you'll see a little triangle pop up, and that tells me that we are halfway down this square. So click on that. I'm going to type in 0.25, and I'm going to do the same thing here. So go to this edge, go 0.25 because that's how far. This is where I want the diameter of the circle to end. I want the edge to be 1/4 inch away from that wall. So you could create a circle in a multitude of ways. So in this instance, I'm going to be choosing the 2-point circle, because if we choose the center point now, yeah, you could get the measurement. You can figure out, hey, how far this is from the center and go from there, that sort of thing. But what's easier for me is I'm going to use a circle with a 2-point that begins on the outside. Click the outside here, so that's where my outer edge is. And I'm going to type in 3/4 inch, so 0.75. Going to do the same thing here. 2-point circle, 0.75. And we are almost done. Just delete these 2 lines because we just use those as a little reference line, and we're done. Our test piece, it is complete, mostly. And what I mean is we've drawn it. Now we have to make this a cut ready file. But one thing that a lot of people fail to do or something, they're before they bring this over to CAM, they're like, hey, what's with all these numbers and all these points and everything like that? Well, everything here on your sketch palette, if you don't want these to appear, maybe it's kind of gumming up everything, it's making this whole thing more complicated than it should be, you can actually hide those things. So our constraints, constraint meaning, this fillet is a fillet, it's not going to change. Our dimensions here, so you click that and it hides our dimensions and our points. So now you just have a nice little clean test piece. And we can call this done. So that sketch is now done. So what do we do with the sketch now? We now have to turn it into a cut ready file because we have the drawing, and now we need to tell our table how to cut this. So we're done with the first part. This is our CAD design. So now we're going to go over to CAM. So again, for Fusion first time users, you're going to click this design option because we're done designing. You're now going to go to manufacture. And now what CAM is basically the interpretation from your drawing to G code. So, your machine doesn't see a drawing, it doesn't see a JPEG, it doesn't see a DXF. Your machine needs to be told in what direction, in relation to everything else, the torch needs to travel in order to cut this. So that's all it is. It's just basically directions like GPS. So what we're going to do now, the first thing you need to do in CAM is create your setup. Now, the default values, I leave these alone because, you don't need to mess with anything. We're not doing anything outside of a simple bracket here, a test piece, so you don't need to mess with any of this. And your post process, the last option here, you just want to name it. So let's just call this a test piece and hit enter. So now your setup is created, right? So your setup basically means what you're cutting. That's the first part of your CAM process. And the second part of your CAM process is how you're going to cut this, right? Or what direction and all that stuff, what speed and everything. So that's the second part of CAM. So in order to do that now, we are going to create a 2D profile. So you do this by either, some people like to go just left to right here. And, it's an easy way to remember it. After your setup, you go to cutting your 2D profile. I personally like to use this option here and right click. And just the reason being because I know I'm just working from that same setup. So just again, habit, but you can go right up here and choose 2D profile. And you could create your profile from there. But I've just gotten in the habit of right clicking this because I have a habit of going into different profiles, creating multiple profiles, deleting them, and all that sort of thing. So I just go here, I right click setup, go to new operation, cutting 2D profile to bring this up. So when you bring up your 2D profile, you get this box here, and this is what's going to allow you to choose a host of things here. So everything from one, speeds and everything, two, geometry, meaning what shape you're going to cut, heights, we don't mess with that. Passes, how you're going to cut this if you want to implement any rules, and last but not least, lead-ins and lead-outs and that sort of thing. So we're going to go to Tool. Now, this is based on the assumption that you have a tool library set up. If you don't, I can make another video on that, but first things first, you want to create a tool library, and then you'll adjust it from there. So basically what the tool library is, it's a multitude of settings that you have for different speeds, and utilizing, a specific kerf width in case you use multiple different nozzles. I only use two nozzles, as you can see here. I use one for 65 amp nozzle for 1/4 inch and above, and I use a 45 amp nozzle for 3/16 and below. So you create that tool library that way. Whenever you're cutting something, you don't have to remember the speeds. You don't have to pull out a chart. You just go here, select the appropriate tool, and it will apply that kerf width value that you have entered as well as your cut speed. So let's pretend that I'm cutting this test piece out of 16 gauge. Let's go library, 16 gauge, select, and you can see it automatically brought in my feed rate as well as it utilizes the kerf value. And I'll show you that in just a sec. So we have our tool selected. I'm going to choose our two circles. That's what we want to cut first. And I will talk about these arrows here shortly after we create this profile. Don't need to do anything with heights. Passes. So passes. We're doing circles here. So, if you've ever done plasma cutting, um, again, assuming that you haven't, but when you do plasma cutting, depending on the thickness of the material, sometimes when the plasma torch begins and as it cuts and it exits, sometimes you could have this like little extra material in there, like a little nub, that sort of thing. And that's usually more apparent when the metal is thicker. So you have a feature here called finishing overlap, which is really cool. So what that means is if you start here, right where the red arrow is, and your torch starts here, this is where it enters to create that circle. And as it cuts, you can actually add a finishing overlap, and what that means is it will continue cutting past that start point. So instead of ending here and exiting out, it will continue to cut a little further past that. And that's just to ensure that it cleans off that little nub there. So, it just gives you a cleaner cut. So let's pretend we're doing something a little thicker. But yeah, I'm going to go ahead and just add a small overlap. We're going to just do like 1/10 of an inch. We're gonna make it really small because these are small circles anyway. So there's that, and then I like to turn on smoothing for everything. So what smoothing basically is it means that it utilizes more data points right here. It actually gives you a demonstration there, which is awesome. But just think of it as like playing a Sega Genesis game and you had all those pixels, it was really pixelated, and think of playing a PS5 game or even a PC game with like really high graphics, like the pixels like way higher pixel rate, way higher resolution. There's more data. So the more data there is in your cam file, the smoother everything is going to be. It's going to create a larger file. I'd say it's negligible. Your computer on really intricate designs may work a little harder to maintain that smoothness, to maintain that, all that fidelity. But, I say it's worth it. I leave it on. And last but not least, you have feed optimization. So you can actually change these, but in the CNC world, we would call this a rule. And what that means is a rule is basically a unique, um, how can I put this? It basically implements a unique rule, a change in the cutting process to just give you a better quality cut. So in this case, it's meant for, circles. So what it does is it slows down the tooling, for better results, basically. It works for like milling, CNC plasma as well, especially for small circles when it comes to CNC plasma. Because again, if you have really thick metal, because the cone, the plasma torch, it's basically a cone, right? So if you cut really fast, um, that fast feed rate might cut like the top part of it off really well, and then as you go down further, it might be a little bevel. They didn't cut, through the material all the way through, so it gives you a little bit of a bevel. So slowing down that cutting just means more heat is applied, and it thoroughly cuts that hole out. So that's what feed optimization is. It's just a rule where it implements a slower speed based on your base speed. It implements a slower speed because of the size of this thing. So it's either really sharp radius or something like that. So let's go and turn on feed optimization, right? Let's go ahead and turn that on. And so it's going to be applied to these two circles because those are the two items we selected in our profile. And last but not least, our lead in and lead outs. I'm going to leave these alone so you can see what the default is, and I'll show you how those look once you change them and adjust them. So let's go ahead and click OK. Right? So you can see your lead in and lead out. Now when you click out of it, you're like, oh, no, where did it go? Just go up here, click the eyeball, and now you have your lead in, lead out visible. So a couple things. One, I talked about kerf value, right? I talked about your tool library and your kerf value. You're going to see the circle here that you drew, and you're going to see another circle right here in the inside. So what that is Fusion is utilizing that kerf value that you entered in your tool library. And what it's doing is, in order to achieve this circle that's 3/4 of an inch diameter, right? Right, or 3/4 of an inch. Um, Based on the kerf value, the circle needs to actually start here. The torch, it needs to cut here, starting here, and travel this circle because of that excess material that will be removed based on that kerf value. So if you see this circle, that's just Fusion compensating so that when your test P is cut out, um, it gives you an accurately, the correct dimension part here. That's all it is. So again, if you see a little circle, it's just Fusion offsetting that circle to cut so that when you cut your test piece, you get that 3/4 inch diameter hole. All right, so going back to this lead in and lead out, I haven't really made any adjustments. I'm looking at them and I'm like, you know what? I don't like this sharp angle here where the torch is going to come in and then start this cut. I want to add a little bit of a radius, right? Because I want a smooth transition for the torch to go in here, go in there, cut this out, and then get out. So let's go back and we're going to edit this. So we have everything selected. We don't need to make any changes to that, but we do want to mess with the lead in. So I'm going to add a radius, right? So let's add a 1/10 of an inch, right? Just something small, just to see how that looks. So we're going to click OK. And now you can see we have a nice little transition for the lead in. And as it cuts, and then the lead out right here, where it's going to continue cutting a little bit more to make sure we get rid of that nub, anything that's created from that lead in, right? Then it's going to lift up, go to the next one, cut, and it's going to lead out again with that nice little radius and that finishing overlap. And that's it. We have our 2 circles cut out. So now we need to do one more thing. We need to cut this actual piece out, right? So last step here is now we're going to go back to setup. Again, something I like to do is I like to go right click, new operation, cutting, and 2D profile. Now I like doing this mainly because when you do that, let me see if it actually does it here too. Okay, so it does. One of the nice things I like is that Fusion will bring over that last tool you use. So you don't have to choose your tool again, because again, it's based under the assumption that you're not going to be changing your tool. You're not going to pause this cut, change your nozzle, none of that. You're going to be utilizing the same tool. So all we need to do now is go here, select our geometry. We're going to choose this outside. And again, talked about this red arrow. I mentioned it, but I haven't talked about it yet. I will shortly. We're going to go to heights. Don't need to change that. Passes. I'll turn on the smoothing just because I have these, this radius here. I want to maintain that. But we don't need to do anything special. And then lead in, lead out. Again, not going to change that. I want to see how it looks. And click OK. So one thing you're going to notice here, and you know what? I'll turn this off. So let's turn that off. So we're only looking at the second profile. If you notice here, our lead in and the lead out are inside our test piece. We don't want that. We don't want to cut into our test piece. So because this is a 2D, flat image, Fusion does not know if this is an outside cut or an inside cut. This is simply a 2D drawing, so it doesn't know any better. So we have to tell it that, hey, this is not an inside cut, this is an outside cut. And for those that don't know, inside cuts are done in a counterclockwise direction, and outside cuts are cut in a clockwise direction. So again, Fusion does not know that this is an outside cut, so all we have to do is we're going to go to our profile, right click, edit, and we're going to go to geometry. Remember that red arrow we talked about? We're just going to go and click it. So careful you don't click the line because it's really easy to choose the line. Just going to go to the red arrow, click it. You can see it change direction. Click OK. And now you can see that our lead in and lead out are outside right there. And let's go and turn this back on. Okay, so um, another key thing here that I want to mention that I didn't really mention as to why I did it, but I made two profiles for this simple piece. And the reason being is because one, there is no limit as to how many profiles you can create for a single setup. But the reason why you want to utilize more than one profile is because you don't cut every shape um, in a similar fashion as you do with everything else. Now, can I benefit from having that lead in radius and lead out radius from this? Sure, I possibly can. I like that nice round transition, and I could probably incorporate it here, especially going here. But what we don't need to add is we don't need to add the feed optimization or maybe even the finishing overlap. Now you can add those and you can have all that incorporated, but I typically like to create a separate profile from those items. And also I always like to cut, my outside piece. I always like to make it my last profile. Well, one, you have to, because you want to cut everything on the inside first and then the outside last. But yeah, you don't always implement the same rules for one piece as you do for another. So that's where creating multiple profiles is really beneficial. So I've created my profiles, I created my setup, created my profiles. Now I want to see if this will indeed cut. So last thing you can do here is again, going from setup to 2D profile cutting to now we can simulate. So we're going to click simulate. No issues found. And here you could select the speed at which you simulate this. So if you're cutting a really slow cut speed, you can turn it up or vice versa. Just gonna put it right there in the middle, push OK. And you can see how that's cutting. And everything looks good. You can pause at any point in this if you want. Another cool thing is the information displayed here shows you what it's running at. And also here, for those trying to price out your work, you can see how long it's going to take to machine this. In my case, it's 24 seconds, but also machining distance. So even though this is a 2.5-inch square piece, you can see the distance it's going to travel because of these circles, the finishing overlap, and all the lead-ins and lead-outs. So, yep, that is our piece. So after that, once you're happy with the design, you're happy with the cam, creating your profile and stuff, last thing to do is just simply your post process. I don't have a post process set up on this mainly because this is my gaming computer, so I do all my design here. I use a separate computer for my post process, but this is where you enter those last values and you create your cut file, and you open up that cut file on your computer at your table and you run it, and there you go. But again, this is just assuming that you have your tool library set up already, you have your post processors set up already, and your post processor is basically it's that translator, basically telling your machine that, hey, this drawing, we're turning it into code for that machine to read. Because again, the machine does not read JPEGs, doesn't read DXF files, it reads code. So that's what you're doing here in your CAM process. You're converting this into code. One final thing, though, that I want to add is when you're doing a simulation or when you're doing a post process, make sure that you have your setup selected. And what that does is that ensures that everything, when you do a simulation or post process, anything in this setup is going to be converted over. And what I mean is if you accidentally have a profile selected, so in this case, I'll select the last profile. Um, if you simulate it, it's only going to simulate that profile that's selected. Or worst case, you have that profile selected, you go to post process, you create your file, go to your table, and you're like, hey, what gives? Why do I only have this outside cut? What happened to my two circles? That's because when you created your post process, you had the profile selected and not the setup. So I say that from experience. It's happened to me when I was first getting into this, but just something to be mindful of. So yeah, again, we did CAD, created this design, went to CAM, we created our setup, our profiles, and again, this is a piece that I really like to use for doing test cuts. You could utilize the width, the height, make sure everything is square on your table, ensuring that you have no bevel, and ensuring how those circles, how they cut. So great piece to use as a test cut piece and a simple design that you could create at home and just get familiar with the CAD and CAM process. All right. I hope that helps. Thank you so much, guys. Bye bye.